Good day, everyone, and welcome to Module 1 Factoring. For this module, we will factor completely different types of polynomials using different methods. In mathematics, there are operations which are the reverse of each other, examples of which are addition and subtraction, multiplication and division, squaring and getting the square root, and so on. Since we will be discussing more topics in algebra, there are also procedures which are the reverse of each other. And an example for that is finding the product of polynomial and factoring the product. And that would be our lesson for the next 2 weeks. So as an example, we have here an instruction wherein we are asked to find the product of the binomials x plus 1 and x plus 2. So if we will try to answer this using your knowledge and skills when you were still in grade 7, you can either use distributive property as a method, or you can use a special product called the FOIL method. So if you use distributive property, all you need to remember is to distribute the first term of our first binomial to both terms in our second binomial. And then afterwards, you just have to make sure that the second term of our first binomial will be distributed to both terms in our second binomial. So to illustrate, our first term here is x plus x. So that means x must be multiplied to our second binomial, which is x plus 2. And take note, the operation between our first term and our second term in here, which is 1, is a plus. So that's why you need to put plus here as well. Afterwards, don't forget our second term is 1, that in which we must multiply it to both terms in our second binomial, which is x plus 2 again. And afterwards, you multiply the x to each terms. So x times x is x squared. X times 2 is 2x. And here, 1 times x, just 1x, or you can just write x. 1 times 2 is 2. Then we combine like terms afterwards. X squared, because it doesn't have any like term. 2x and x here are like terms because both of them has a literal coefficient x. So take note, to combine like terms, we just have to add their numerical coefficients. It would be 2 here, and this is 1x, so that's a 1. So 2 plus 1 is 3. Then we copy the common literal coefficient x. And lastly, our constant term, we only have the 2 in here. So there's no other constant term, that's why we just have to copy it. And double check whether it's already in simplest form. So if you notice there are no more like terms, this is already simplest form, so this is our answer. The product of the two binomials given to us. Now, we have here another example, but the instruction is not anymore finding the product, but instead, we were asked to find the factor. I want you to pause this video and guess what would be the factor of x squared plus 3x plus 2. Very good. Good observation. If you notice, number 2 is actually the answer in number 1. So that means the answer here is x plus 1 times the quantity of x plus 2. So notice that the given a while ago, in which the answer is x cubed plus 3x plus 2, it's just the reverse of what we're doing here now in number 2. So that's why finding the product and finding the factor of a polynomial is the reverse of each other. This leads us to the conclusion on what does it mean to factor. When you're asked to factor, you just have to express a given polynomial as a product of polynomials. Example for that, think of a 4. If you're asked to factor it, your answer could be 4 times 1. You can also answer 2 times 2. So you're expressing it in terms of product of two different numbers. In advance, this is an example. If you're given with x squared minus 1 and you're asked to factor it, there are two binomials here in which the operation is multiplication. When you multiply these two binomials, that will result to x squared minus 1. Here you go. That's factoring. So when you are asked to write x squared minus 1, such as the product of x is 1 x minus 1, you are asked to factor. When we're asked to combine two different binomials by multiplying them, okay, that's finding the product. From your grade 7 lesson, finding the product of polynomials, we're just doing the reverse of it. So why is it that factoring is very important? So now, the main reason why factoring is a very important topic in algebra is because we can use it when we simplify rational expression. So right after module 1, our topic would be rational expression. And you will not understand rational expressions if you don't know how to factor. As an example, in module 2, you will be asked to simplify x squared plus 5x plus 4 over x squared plus 2x plus 1. So usually, the instruction, when we reach this module, you'll be asked to simplify. So to simplify that, you will be needing the concept of factoring. So as an example, in the numerator, x squared plus 5x plus 4, if you factor it out, that would be x plus 4 times the quantity of x plus 1. Try to check yourself. When you use distributive property to multiply it, or FOIL method, you will be getting x squared plus 5x plus 4 for that. In the denominator x squared plus 2x plus 1, when you factor it, you will be getting the quantity of x plus 1 times the quantity of x plus 1. So if you notice, we have two common factors from the ones in the numerator and the ones in the denominator. So we cancel that out. There you go. We're able to simplify it. What is left is just x plus 4 and x plus 1. And this is now the simplest form of this rational expression. Without understanding the topic factoring, you will be able to simplify rational expressions in the future. At the same time, when you reach lessons under trigonometry, calculus, once you deal with real life situations involving directions and vectors, um, simplifying simplifying equations would be very essential. So the question now is, how do we factor polynomials? So we have here some steps on how to factor polynomials. So there are 3 steps in here. First step, to look for common factors among the terms of the polynomial. And if there is, factor it out. Second step is to look at the number of terms in the polynomial. So it depends on the number of terms. And if you know the number of terms, you would know what are your options when you factor in. And finally, third step is to check if any of the factors can still be factored further. So we will look into the steps one at a time for you to better understand it. So for our next lesson, we will be talking about the first step, in which it focuses more on common and nominal factoring, or CMF.